guys. There we go. Let's see if this works. Okay, so a couple of things I want you to understand, like as you're solving equations and inequalities, you can get 3 different kinds of answers. You can get an answer where you get a number, okay? That is right here, like x equals 4. You can get an answer where you don't get any kind of number, which is no real solution. You can get an answer where it's always true and you get all real numbers, right? So when you get an answer like x equals 4, x equals 1/9, or w equals negative 19 over 35, I don't know, you get like a number, right? It's called a conditional equation because the value of x is conditional upon that particular value, okay? Identity is where it's always true. It doesn't matter what number you plug into, 9, negative 8, 45, negative 4 million, negative 19 over 35, it will always work out. And then there's the contradiction where it doesn't matter what you put in, you're not going to get the answer. Also know that you can get x equals 0, and 0 is a number, as an answer. You get x equals any number, where 0 is also a number. You can get all real numbers. The symbol for that is this R, this double R. And you can get no real solution, which is like a 0 with a line through it. All right, so let's look at those kinds. Okay, these special kinds of equations, because you're going to run into them, and I don't want you to freak out. Okay, so here we have this guy. Remember, the parentheses tells us we need to distribute. So we have 3x, and then 3 times 2 is 6. So we have 3x plus 5 equals 3x plus 6. And I like my letters on my left. I'm going to subtract this 3x over here from this 3x, and we're not going to freak out just yet. Those cancel. 3x and 3x, we get 0. So 5 equals 6. In no world, in no situation, just 5 equals 6. $5 doesn't equal $6. 5 dogs does not equal 6 dogs. They never will ever equal each other. This is never true. Okay, so it is a contradiction. Okay, and so you would write no real solution. Okay, or depending on, if it's asked you to pick if it was contradiction or identity or conditional, or if it asked you to, say it's always never true. Okay, so it's one of those. It's either contradiction, no real solution, never true. Those all mean the same thing. Let's look at another one. This guy. Let's distribute the 6 first, and then we're going to deal with the 2, and we're going to have to do some combining of like terms. Okay, 6 times y, and then 6 times negative 1. So 2 minus 6. So you have $2 in your pocket, but you owe me $6. You owe me $4. Notice we have the exact same thing. Okay, you can stop there if you want. I'm not going to. I like my letters on my left. So I'm going to subtract 6y, this guy, from this guy, and they cancel, and I get negative 4 equals negative 4, which is a true statement, right? You owe me $4, you owe me $4. That will always, always, always be true. Okay, and so this is all real numbers. It's important that you write the word all real. You write this word real, just like over here. We wrote the word real, because there's things called imaginary and complex numbers. All right, so the answer to this guy is all real numbers. Okay, you can do the double R, or you can say identity. They all mean the same thing. Let's do another one. All right, this looks complicated, but we can do it. We just tiny baby steps at a time. We need to distribute that 7, okay, and we need to distribute the 4. That's the very first thing I'm going to do. So 7 times 3, 21. 7 times 5, 35, and then I'm going to bring my 9 down. 4 times 6, 24. 4 times 11, 44, minus 3x. That's the minus sign. All right, now I need to combine like terms. Okay, so I have a 35 and a 9. So 35 plus 9, that is 44. Hold up, wait a minute. All right, here we go. All right, then I have this negative 3x and this 24x. So 24x minus 3x, that's 21x. And I have plus 44. Again, notice they're the exact same thing. But just so we're, 100% sure, let's finish it out. I'm going to subtract this 21x, because I like my letters on my left, from that 21x. They cancel, and I get 44 equals 44. And that's always true. So you can write all real numbers. Or you can write the symbol for all real numbers. Or you can write identity. Let's go another one. Write this guy. Right, we're going to distribute this too, and then we'll deal with some combining of like terms. 4x plus 4 minus 2x equals 8. So 2 times x is 2x. 2 times negative 3 is negative 6x. Right, now let's deal with like terms. 4 minus 2x is 2x plus 4. 8 minus 6 is 2 plus 2x. It's okay if you want to write 2x plus 2. Then I need to continue to solve it. So I like my letters on my left. So I'm going to move this 2x over. I'm going to subtract it. So those guys end up canceling, and I get 4 equals 2. Well, 4 does never equal 2. So no real solution. Okay. Or if you wanted to do the 0 with a line, any of those three would work. Look at another one. Okay, you can do it. We're not going to freak out because it's long and big. We're going to distribute the 7. 7 times x, 7 times 6, 42 equals 15x plus 42 times 3. All right, now we need to combine like terms. So x, okay, and then these guys need to talk over here. So 7x plus 5x, that's a 12x plus 42. And then a 15x minus 3x, that's a 12x. 15 minus 3 plus 42. See that they're the same thing. All right, but let's just double check. I'm going to subtract this 12x over here because I like my letters on my left. And I get 42 equals 42, which is always true. So you can write the double R, or you can say all real numbers. It doesn't matter what number, decimal, fraction, whatever numbers. I substitute into that equation. I'm going to get, it's going to work out. Oh, and that's it. Okay, so we talked about the 3 things. Go back real quick. We have contradictions where it's never true. You have identities where it's always true. You have conditional, where you get like a number, which is what we did in some of our other videos, where you get like a decimal or a fraction or a 0 or a 4 or something like that. Okay, so go work on your homework for this. Let's go back to it, to this section, and then go watch your next video. Bye.